Welcome, everyone. My name is Hal Turner. Welcome to our webinar about our new general chemistry courseware. We're going to talk a little bit today about the new courseware itself and a little bit about the authoring platform that enables you to customize it. My name is Hal Turner. I am the partner manager here at the Open Learning Initiative. Let me introduce you first to chemistry professor David Guerin.
Hey, how's it going? Yes, I'm in the chemistry department at Carnegie Mellon. I've been involved in education, research, and development for a long time, I guess, more than 20 years. And I'm happy to have Sandy here showing the course we've created. That is the first thing we've ever done that covers the entire chemistry.
We have Sandy Razor, who is the director of the Chem Collective. She's going to take over from me and talk a little bit about the chemistry course.
Thank you all for joining today. Really excited to show you this resource. My background is in chemistry education and instructional design. I worked as a high school chemistry teacher for about 10 years, and about 7 years ago transitioned into instructional design, developing online content both for the Open Learning Initiative and outside companies as well. Recently, I've come back to Carnegie Mellon and am working in the chemistry department with Dr. Guerin on this course and a couple of other projects as well. So let me go over the agenda for today first. We will take a look at the courseware in some detail, kind of give you a high-level view of what to expect, and then we'll jump into the courseware itself and take a look at some of the details. Talk a little bit about OLI, the philosophy behind OLI, the learning dashboard, which is what allows the instructor to view the student data, the authoring platform, which is new to OLI. So those of you that are already familiar with OLI, this may be something new to you as well. So it's really cool. It allows you to customize any part of the course. Hal will talk a little bit about the logistics of getting OLI into your LMS, things of that nature. We'll talk about some strategies for using the courseware in your classroom. Finally, we'll give you access information so you can preview the courseware yourself and also use the authoring platform. And then finally, we'll take questions and get your feedback. So the courseware covers topics that are typical for first and second semester general chemistry. The first semester general chemistry will be available for the fall semester, so August 6th. The unit level topics that you see here, the ones that have the asterisk, are ones that are currently available. So if you want to preview and you get that access at the end of the webinar, those are the units that you'll be able to preview now. The other 2 units will be available by August 6th for use in the fall. The second semester content, we do have 2 units currently available for preview with that. The others will be available for spring of 2019. We're targeting beginning of January for that. So what makes this courseware unique and I think has the potential to be very impactful for chemistry education is a number of things. First of all, it is fully integrated. So it's likely that many of you currently send your students to a number of places for their work. So they may have an online textbook, a separate online homework system. You may have additional practice problems that you give them to do, and they're kind of jumping around in different places. This courseware is fully integrated. It can replace both the textbook and the online homework and also make it more effective because the homework/practice problems are fully integrated within the text. So it's not like, okay, read a bunch of text and then do a bunch of problems. It's kind of all together. And when we look at it together, you'll be able to see that. And then additionally, now with the authoring platform, if you have your own homework assignments that you usually assign to students, those can be also incorporated right into the courseware as well. It's highly interactive experience for the students because students learn by doing. The activities and practice that the students will encounter are numerous, they're scaffolded, and they include immediate, detailed, and targeted feedback. Again, things we'll take a look at in just a minute. Virtual lab activities. I know some of you that are on the call are familiar with the Chem Collective and our virtual lab activities. Those will also be incorporated into the courseware. There are cumulative scenario-based adaptive activities at the end of the modules, and we'll take a look at an example of that. Of course, quizzes for summative assessments and the detailed instructor feedback for the learning dashboard. We'll take a look at the learning dashboard, and as I've already mentioned a couple of times, the OLI authoring platform allows for the content to be edited. So now I want to jump right into the course. Okay, so when you first open the course, you see that our unit level topics, which is what we saw on the PowerPoint, and then within each of the units there are several modules. So this kind of gives you a little bit more detailed view of the topics that are covered in the first semester content. Again, up through chemical bonding, molecular geometry is what is currently available for the preview, and adding 2 additional units for the fall. So I want to jump into a module here so you can get a good idea of what this looks like to the student. Okay, so each of the modules includes learning objectives. So the student is initially presented with the learning objectives for that module. So here, starting out, we're looking at some basic stoichiometry. We have some text and an example. And we have 2 different types of activities. Well, I should say 2 different categories of activities. Learn by doing activities and did I get this activities. The difference between the 2, and we'll look at this in a number of examples, is that the learn by doing activities are scaffolded. So you can kind of think of those as guided practice for the student, whereas the did I get this examples are not scaffolded. So sometimes the scaffolding is relatively simple and straightforward, as is the case here, because this is a relatively simple problem for most students. So the scaffolding comes in the way of a hint. In the hint, they're given the conversion factor to use. 4 numeric input problems, which there are many numeric input problems. If they get the incorrect answer, they do get a second chance. So this says incorrect, try again, gives a little bit more information. On their second incorrect answer, they then just are given the answer. So there's a second example there. Getting into now a little bit more complex problems, pulling in particles, molecules, atoms. Again, we have the learn by doing activity with hints. I did want to point out as well, when the activities are multiple choice, the choices are based on some common errors. So for instance, if they choose this one, this is that they flip-flop their stoichiometric factor, so that's the feedback that they get. For this one, what they've done if they've gotten this answer is that they skipped a step. So the choices, again, are based on actual errors that students might make. And then we end here with a bit more straightforward. Did I get this question? Again, removing that scaffolding of the hints. Moving to a bit more complex problems. So these problems, your typical stoichiometry, given mass of product, what's the mass of the reactant. We've got a graphic organizer in the example. With many of the more complicated problems, we've incorporated interactive examples. So this is an example of our interactive example. So this gives the problem. Along the left-hand side here are the steps to work through the problem. So the student clicks through here and the problem unfolds as they go through and click through, as opposed to your standard example. So making the example more interactive for the student. Significant figures, had a question come up about significant figures. There is obviously content dealing with significant figures in the first unit, and for situations where we are asking for a particular calculation and the answer in a certain number of significant figures, it is graded to that number of significant figures. Once we get past there in the numeric input, we have a range of values that are acceptable for the numeric input problems. For this, again,
I wanted to know if OLI comes with a periodic table.
So there is a periodic table that is referenced in the courseware, and for all of the calculations that are done in the courseware, those values from that periodic table are used. So I wanted to look a little bit at this learn by doing. This is a little bit more complex problem, and so the learn by doing is a little bit more elaborate. So we have our interactive example. When we get to the learn by doing, as opposed to just, okay, do this problem, we're going to first help the student get the dimensional analysis set up. And then they get to do the calculation. So again, as I mentioned, the learn by doing sometimes are just hints and sometimes involve a series of steps. Here we get to some more learn by doing activities that include hints. This one's going to give hints that kind of talk the student through the process. The next type of example involves volume and concentration of solution along with mass. Increasing complexity a little bit again. This one includes a video example that walks the students through a problem. And then again, a learn by doing with a hint and a series of numeric input. With the incorrect answer, the student is asked to try again, given some information as to how to proceed, and then if they get an incorrect answer, they have the full solution so they can get the correct answer. On the limiting reactants page here, we have used one of the Phet simulations. So it's likely, I would think that many of you on the call are familiar with the Phet simulations, and we've incorporated them a good amount in the courseware. Basically, I've tried to use any of them that were in HTML5 within the courseware. With the Phet simulations, as opposed to just, hey, here's this cool simulation, go see if you can kind of do something with this, there is specific steps for the student to follow and then follow-up questions to go with that. So for this one, they're going to click on molecules, they're going to do the combust methane and molecules of this and 8 molecules of that, and then they're asked follow-up questions. The first several questions here are basically just recording the information from the simulation, but then the final question asks them to interpret something about what they've recorded and about what they did in the simulation. So there are actually, for this one, several similar type questions where they're going through and doing specific things with the simulation, asked to interpret that information that they're observing in the simulation. For this particular Learn by Doing activity is a series of questions to get to what is the limiting reactant. So this part is, the main part of the problem, as opposed to just, get the answer. Let's break this down into steps and then identify the limiting reactant. Stepwise with hints for the Learn by Doing, and then we get to a couple of did I get this questions, which again, more straightforward, kind of pulling away that scaffolding, a self-assessment, so to speak, for the student. The percent yield here, similar situation as we've seen on the previous pages. The last new content page for this module is titration, and there are a couple of new features here, so I did want to take a minute on this page and take a look. So this is a slideshow. We have these to illustrate certain concepts. So this particular one, we are going through a titration and illustrating that in a more visual manner as opposed to all of the text before, of course, explains it, and then we have the slideshow that again looks at it in a little bit more visual manner. Also have an interactive example for a titration problem. Again, tended to reserve those for your more complex type of problems.
We have a quick question about the practice.
Yes.
Are any of the questions in the practice algorithmic?
No.
Okay, so they're not dependent on any of the inputs.
You mean parameterized?
I'm guessing. I'm guessing to the person who asked if the questions are algorithmic. Are you asking if they're dependent on parameters, where they would change dependent on different inputs? Is that what you're asking? Right.
Yeah.
Yes. No. These are not. These don't change. They're static.
Yeah. There is an adaptive part, which is actually what I'm just about to go into.
Right. We do have adaptive parts later on.
Some of the virtual lab activities, which actually are not yet incorporated, are parameterized, and so different students will get different values and therefore have different correct answers. Like I mentioned, that will be incorporated, but in terms of what you're seeing now, there is not the capability for parameterization.
Do you see parameterization or pooling in the scored assessments?
Not currently, no. At the end of each module, there is an adaptive activity that is many times scenario-based. Sometimes it's just additional practice problems where it doesn't really fit to have a scenario, but we did try to incorporate scenario-based problems as much as possible. So while they are scenario-based, they're also adaptive. So for this particular example, if the student gets the correct answer, you just have the correct feedback and they move on. And if they get to the second one and they have the correct answer, and they get the feedback and move on. If they have the incorrect answer, for many of these problems, not every one, but for many of them, they get some additional help in the form of additional questions to answer the problem. So your feedback says, use the activity below. It's going to help you set up the dimensional analysis and then try again. So the student would go through and set this up, and they would be able to see if they are setting it up correctly or not, and so on. So they'd get that set up, and then they would get feedback, okay, try again. So hopefully they'd be able to get the correct answer there. If they did not, they're given the correct answer. In a similar fashion, for this particular problem, if they had the incorrect answer, for this one, the practice is set up your steps to get to the correct answer. For quite a number of these, again, incorrect answers produce a series of problems that will help the student get to the correct answer. For correct answers, there's no need for additional remediation, and they just move on throughout the activity. All of the modules end with a module summary, a quiz. Now, Hal was just asking, and maybe somebody online asked you about pools for the quiz. Currently, there are no quiz pools. We are already planning for improvements and future iterations, and do understand that that is something that I would think a lot of people would want, and something that is worth doing. That being said, you do have the option of putting your own quiz in as well, or adding questions to this with the authoring platform. In addition to that, at the end is the end of lesson questions. This is a metacognitive exercise for the students to go through each of the learning objectives and think about how well they learned the material, as well as questions they might have for the instructor. Okay, so that is your typical module in the course. I know we had a couple of questions interjected there, but I wanted to take a little break, actually a little breath for myself, and give you a minute to kind of think about that and see if there's any more questions related to the courseware itself. We will talk about the authoring platform and the learning dashboard in just a minute, but see if there's anything else specific to the courseware that there's questions on.